Hello physics students. Yesterday we learned about finding force components. Remember, a force component is a part of a force that acts in a particular direction. So for example, if I have a push broom and I take this and I hold it like this, how push brooms are used, and I push on the broom in the direction of the handle, then that force this way has a horizontal piece and a vertical piece. And yesterday we found those using scale diagrams. We used a ratio to convert a force to a manageable length, and then we drew that force at the proper angle and the right length, and we made a little right triangle out of that force. Then we measured those legs of the triangle with a ruler and used a scale to convert back to newtons. Today we're going to learn how to find force components using sine and cosine functions. So of course this will be the more accurate, the more precise way to determine force components. Again, you need to know how to use force components, find force components with drawings, because that's part of the Regents curriculum. So let me step aside and give you a chance to copy this down. Okay, so we have a situation like I just did here, pushing a broom, a worker pushing a broom with 100 newtons at 60 degrees to the horizontal, and we're to determine the x and the y components. So what we do is, once again, we draw the force. We draw the force roughly to scale. So 45 degrees looks like this. 60 degrees has to be a little bit steeper, so maybe like this. How long should you draw it? Well, long enough to, be so your diagram's not too crammed. But the length specifically doesn't matter, because we're not going to get the component magnitudes or lengths from the drawing aspect of the problem. So next what we do is we turn this into a right triangle. This, of course, being a 60-degree angle here, 60 degrees to the horizontal. And then we draw in our force components. This force goes down and to the right at the same time. So right here I'm going to draw a downward component, straight down. And you need an arrowhead on that. So it's not up, it's down. Right? You're pushing that broom down. And then there's a horizontal component, because this force tends to go to the right. Okay. And I label these F in the x direction and F in the y direction. So there's my diagram, my force diagram showing the components. So the first thing we're to find is the x component. That's part A here. And notice that that is the angle. Oh, I forgot the 100 newtons right here. So this being angle, this being a right angle here, this is therefore the hypotenuse. So we know the hypotenuse and we know this angle, and we're looking for this side. The trig function that relates those pieces is the cosine function, because this is the side adjacent to the angle, and this is the hypotenuse. So once again, you've got to write a formula when you start your calculations. Cosine theta equals adjacent over hypotenuse. Okay, so there's my formula required in Regents calculations. Next, I'm going to plug in my numbers. Okay, the adjacent side is the x component that I don't know. And the hypotenuse is 100 newtons. Once again, a reminder, in this step, you need your units. Leaving this little degree symbol off on a Regents test makes you lose half credit on this problem. Leaving the equation off, but having all the units, also half credit lost. Okay? All right, so what we're going to do now is multiply the 100 to the other side. Fx equals 100 times cosine of 60. Maybe I'll write that down, but you don't have to write this down when you're solving your problems. That extra step. Now what you do is you just take your calculator and you plug in the one expression, get an answer. I do want to point out that Texas Instrument calculators may be in radian mode. And you use radian mode in math class very often. So you might have to be switching back and forth between radian mode for math and degree mode for physics. Okay, so make sure if you don't get this number that I'm going to write down here, you are probably in radian mode. But this turns out to be exactly 50 newtons. Okay, I'm going to pause the video here to allow you a chance to catch up if you need to. Okay, moving on to part B, we are now going to look for the Fy, the vertical component. So what we have in the beginning, we were given the hypotenuse and this angle. This side is opposite of the angle, opposite side, and we have the hypotenuse. The trig function that relates those three variables is the sine function. Sine theta equals opposite over hypotenuse. Once again, you need that equation first. Now we can plug in our numbers. Sine of 60 degrees equals the opposite side, which is Fy, over the 100 newtons. And then we can multiply this 100 to the other side. So we have 100 times sine of 60. You could just punch that in on your calculator, and you should get 86.6 newtons. Okay. I'll pause to give you a chance to catch up with the notes. Okay. One more thing I want to show you. Sometimes we don't know the angle. That might not be known. Let me, so 50 newtons, let me just say this. When I push on this broom, when I push 100 like this at a 60-degree angle, right? So tilt it up at 60 degrees, push 100. The force that slides the debris across the floor is not the 100. It's only the component of 50 newtons horizontally. 87 newtons of effort goes into the floor. So I'm pushing this broom, bristles into the floor and horizontally. Into the floor with 86.6, horizontally with 50, all achieved with one 100 Newton force directed like that. Okay? So let's suppose I wanted a horizontal component of 60 newtons instead of 50. But I'm still going to push 100 newtons. So Okay, so what I would do in this case is once again sketch a force into the floor like this. Exactly what angle, we don't know. How long? Well, you know, just make something big enough so your diagram isn't too cluttered. And we're going to turn this into a right triangle again. So this pushes the broom down into the floor. Oops, not quite straight down. Let me. A little bit better. And horizontally at the same time. Don't forget those arrowheads. Again, on the Regents, you could lose credit for that. Oh, Okay, so that's what we know. That's what the problem gave us. So now that we're looking for this angle, we look and see that we have the side next to it, which we call adjacent side, and we have the hypotenuse. So the trig function that relates the adjacent side, the hypotenuse, and the angle is the cosine function again. So this time, once again, I write out my formula. But now, theta is the unknown. The adjacent side is 60 newtons. The hypotenuse is 100 newtons. The Newton variables or units drop out. And if I divide 60 by 100, I get 0.6. Now, how do I find the angle? I need to do inverse cosine of both sides. So right now I have cos theta equals 0.6. So if I do inverse cos of both sides, I'm left with theta is equal to inverse cos of 0.6. And now I could just take a calculator and I get 53 degrees. So at 60 degrees, I had a 50 Newton horizontal component. If I go to 53 degrees, a little bit less than 60, I get more horizontal component because I'm tilting this more horizontal, and that'll lengthen this x part and shrink this y part. Okay? And 53 degrees instead of 60. If you wanted to find the vertical component for some reason, you could also use the Pythagorean theorem if they asked. And then you would say, okay, the hypotenuse is 100. We know the x component is 60 newtons. And we want to know the y component. And then you would have to solve by squaring things out, subtract this from both sides, and then take the square root, and you would find the y component. So any of the math functions related to trigonometry you could use in tonight's homework. So that's it. Once again, we draw the diagram to scale, not to scale, but just kind of estimating to scale. So just kind of freehand, make it into a right triangle, and use sine and cosine or possibly the Pythagorean theorem to find what you're looking for. Okay, so that's it for today. I'll see you in the next physics video.